And now it's time to officially welcome our first keynote speaker for this day, which is from Opswat and Hitachi, who will share his insights on the topic data sanitization for the financial sector. And to deliver this, I'd like to extend a very warm welcome to Mr. Ashwin Mittal, Regional Head at Opswat. Please welcome him with a big round of applause.
Good. Am I audible? Okay. Good afternoon, everyone. Good afternoon, everyone. Okay. So she's already set the tone how to get the people talking, right? Okay. So I'm here from Opswat and I head the region for Opswat. Before I start talking about data sanitization, which we are about to talk about, I will just give you a small brief of what Opswat is all about and how we came into the industry and what we've been doing so far. So what we are actually trying to do, we are here to protect the world's critical infrastructure, and when we say the world's critical infrastructure, it is not limited just to the IT, but also the operational technology which is deployed in all the sectors, be it manufacturing, defense, pharmaceuticals, or any other critical energy sector or power sector. So we have a certain motto on which we are working, which is we trust no file, we trust no device, we protect all the critical infrastructure that is there in any of the organization or in any of the sector that we address to. It's been almost 20 plus years since we've been there in the industry. We were primarily into providing solutions to the various OEMs in the very beginning, but later on we realized that there is a lot of protection work which is required to be done. We are probably only working on the detection mode for a very long time. I think the industry which we have seen has graduated from detection to prevention, and it took a decent amount of time, and yet what we see is that still there is a lot of detection technologies deployed in most of the organizations. The reason being, we all see a big scope of false positives, and therefore we are scared whether to go into the prevention mode or not. There's a big gap which CISOs generally struggle with, that whether to deploy in prevention mode or not. I think there are lots and lots of technologies that we talk about, be it DLP, be it IDAM, be it privileged access management, and so on and so forth, where we really struggle what really we need to see that ensure and see that whether we can actually configure it in such a way that we can do it in a prevention mode. We're there in almost 20 plus countries across the world. But hey, my intention is not just to talk about Opswat. I would just like to bring to everyone's notice that how the threat profile has changed over the years. I believe there are a lot of CISOs who are here, and I'm sure what we are generally having a thought is that we have deployed almost all technologies. We are protecting the application, we are protecting the network, we have zero trust network nowadays, we have SASE deployed. So I believe that there is no threat that generally we are going through, right? But see here, what's happening. This is one of the data which I picked it up from DSCI website itself. What do they say? What is the the biggest threat, or what are the biggest malware things which are there? So you'll see that ransomware and adwares are one of the biggest, and cryptojacking. These three are the typical three types of attacks which most of the organizations are facing these days. Now, how do these attacks generally are generated and where do they land up in the organization is an area where most of the CISOs are struggling to work. This is a very interesting slide because it addresses, it is talking about the file-based attacks. So you will see that more than 10 types of these are the typical largest 10 file types of attacks which are there. Again, data provided by the DSCI. See the area of from where this originates, email. And I don't think that what we are thinking right now on the email is enough. What have we been talking about the email security? Anti-spams, anti-phishing, right? We probably deploy a DLP solution integrated with the email. But what is the psychology that we deploy the email security with? The intent eventually is to see that we do not receive any spam emails. We do not receive any phishing attacks, which is again hyperlinks. And probably no exfiltration should happen, right? But what about the files which we are receiving? Do we really, are we really scanning them through? No. So that's where a big gap of attack is available for, or the surface is available for the attackers, where they can actually sneak in any ransomware attack, any adware attack, or any kind of attack that they want through a file system. Another source of attack, this particular thing was in power and energy sector. Again, you will see one of the most primary ways in which this particular attack was generated was either through email or through the software supply chain management. So what does the software supply chain management means? A lot of software development is happening, right? What we do is we integrate a lot of open source along. But when we are integrating these open source, how well we are able to harden it? Are we able to see the vulnerabilities around that? Do we really have any solution which can check before the integration of the software supply is happening? Dark race ransomware. Again, you will see the most important source of attack: phishing, email, social engineering. What do these attacks eventually represent to us? That the threat now is not just limited to your network or to your application layer. The attackers have become smart enough that they are embedding attacks in files, and they are sending you through various mechanisms. They're seeing that they can upload things. So just imagine a very simple way. If I'm an attacker and I want to compromise your network, what is the easiest way? Let's go to a bank. I just open an account, I upload my KYC document, attach a script in it, and upload it. Now, how many banks really have that solution which can detect the embedded script? That's where I'm sure that there are a lot of banks who have deployed it, but are all of them really applying that kind of a solution around that? Because so far we have been concentrating only on the network and application layer. We say that we have already deployed a WAF, right? But what happens with the WAF? WAF will only look into the network layer or the application layer or the HTTPS layer. It'll check the header, it'll check the payload. But what happens to the file which has been uploaded, the KYC file which has been uploaded? That'll get unnoticed. That'll get inside to the network unnoticed. And it'll land into the storage straight away from there. And what happens once a Trojan or a malware enters into the storage of any department? The whole data is now exposed. We have something called DPDP now, and we are all really scared about that. Now just imagine that a simplest way of attack has been to enter through this mechanism of KYC upload. A 5,000 rupees account which I'm opening with the bank, and now I am very easily ready to access the complete data that I want. So what do we do at Opswat? We ensure that these files entering through any of the ingress points, we will take care of it. We are going to ensure that we sanitize all these files, be it any ingress points. So typically we have 4 or 5 mechanisms in which any file can enter into our systems. One, obviously through email. That is one of the biggest portfolio through which the files can enter. Almost 80% of the files that we receive are through emails, right? Till 10 MB or maybe 20 MB that's what we generally see. If in case we do not want, we have a different mechanism, what we look for is through uploading things through portal, like KYC is one of them. Like a lot of government departments where the citizens have to upload data. Passport, for example, they have to upload their documents. For visa applications, we have to upload our documents, and so on and so forth. The third more common way in which the files enter is FTP. supposedly the file size is large, 50 MB, 100 MB, 200 MB. A lot of agents been connecting to the banks. A lot of third-party distributors connecting to the manufacturing department. They have to upload data to the central unit. So what they do, they share all their data through shared file transfer, and they upload it at a central repository. Now, unluckily, we see them as a trusted vendor. What we deploy for them is a zero trust architecture, that's it. A network layer protection, an application layer protection. But are we really protecting what is coming from them to us? We don't know that, right? So this is where the concern starts, and this is where it can become a huge area of concern, because suddenly the file which has entered into your system can completely disrupt your whole data privacy in a whole. Lastly, through USB or removable media, we have a lot of vendors in our data centers. We have a lot of vendors coming into our plants, into our manufacturing units. What do we do about that? At the max, we deploy a single station on which they deploy the particular file, and then we take it from there. But are we really sanitizing it? And on top of it, we have a compliance issue. We have to open USB ports for them. We do not want that. We really do not want any open ports for any of these vendors. We really want that whatever is coming in should first be checked and then only allowed, or maybe that particular device should not be allowed inside. We should have a mechanism in which this should flow in seamlessly after sanitization to our systems. So this is where Opswat is playing a very important role. I will also show you certain demos today. I'll not be showing it in a live way, but we have created certain videos how we are protecting certain files. So that was an example of trust no file. So that's one motto which we used to take care of. The second motto is trust no device, which is we are not going to trust whichever device is going to come has to be complied, only then they should be allowed. And I'm sure most of the organizations have this on their priority list. But yes, files is becoming the next priority list, which we are seeing stages. So as I said that we will be protecting you at all the stages of ingress points, whether through email, whether it's on a cloud, whether it's on a cloud storage, whether it is coming through a portal, even if it is through a proxy, you have an ICAP integration. If it is coming through a WAF, we can have an ICAP integration if you have portals. And we have very decent organizations, lots of financial organizations who are using these solutions to ensure that these files which they are receiving are sanitized, and only then they enter into the storage of the departments. So I'm not going to take a lot of time talking about how we are doing that. You can always touch base to us, and we can then take you deep dive into the solutioning part. But yes, what benefits we are going to provide to you as Opswat as an organization, we support more than 150 types of files. We provide comprehensive email security. Like I said, that right now what the generic thought is anti-phishing, anti-spam. What we are providing you is whatever files are coming into the system should not reach to the user before it is completely sanitized. And when I mean sanitized, we are not going to use just a single technology of AV engine. That is just one very small part of it. We have something very interesting and very effective that we call as content disarm and reconstruct. What we do here is the typical AV engine, what they will do is they will check the signatures. Through the signature base, they'll check the file, that whether it is there or not, and whether there's any threat or malware, etc. What is the efficacy of that particular AV engine is something relative. Some may give 60%, some may give 40%, some may give 65%. But is that enough? Obviously no. Even the attackers know what these signature-based AV engines are going to protect. They are smart enough. They are being paid well. They are paid better than what we are being paid, right? So eventually, they are going to create something more intelligent, and they'll send it through a file. But yes, we still do that scanning part, and we don't do that with just a single AV engine. We use more than 30 AV engines while we do that. So first, because the signature-based sanitization is the fastest mode, we first check through that. But hey, that's not the only thing that we are going to do. Because what do we do if somebody has just changed a couple of lines in that script of your malware? No AV engine is going to be able to check that, right? So we have something called content disarm. We break the file into multiple components. Each object is then checked individually, and all the active components in that is extracted out, and only the non-active components are reconstructed in the same file format and sent back to the users. As a result, your file type is not changing. You are still able to use the file the same way you was intended to use, and you are yet have a file which is removed with all the active components. Thereby, what we are able to achieve is a 0-day protection. So suddenly we have got into a protection mode rather than prevention mode, rather than just a detection mode. As I just said, detection is just the malware scanning. But what about the prevention mode? So I have now just broken the file into components. For example, a Word file. I just break that into text, images, logos, QR code, or whatever is there. Whatever is embedded in it, macros, OLEs, can all be removed, and a sanitized file can straight away be delivered to you. Now this file can come to you in the format of email. It can come to you in the format of in the form of SFTP, or even a file upload. So we provide all these solutions, as I said, software supply chain. So whatever open source that we are using, we ensure that before you integrate them together, we do that vulnerability assessment, we do that checking of the files for any malware, any open doors, and we plug that up. Now I will just show you how a password protected file, which generally you receive on an email. Can anyone tell me if you can scan a password protected file on an email? Or any password protected file? Does any scan engine scans it? No. Okay, so we have developed a particular workflow in which we can ensure that you do not receive any password protected file without being scanned. It will not be delivered to you.
Hello. Today I'd like to introduce you to how the Opswat email security is handling password protected attachments. To start with, I'm going to show you a custom tool that I'm going to use in order to send an HTML email. Here I can just add my email body. As you can see, like it happens generally, the users would just add the password in the email body. In terms of attachments, I'm going to add this archive as attachment to the email. I'm going to send it to this test mailbox. So I'm just going to say start. This email has been sent. If I just refresh here and go to the history, this email was now sent. What I can do is just check my mailbox, and just going to do a quick refresh in the mailbox. And what you see here is the actual email. You see the email body here, but there's no attachment. And we remove the attachment at this point because we cannot say for sure if it's clean or not. But what we do instead is we add this disclaimer, and this disclaimer can look very differently. You can customize the way the disclaimer looks and even the text. The most important part of this is the URL, where I can just click. This web page opens where I just have to put my password, and I just say rescan email. It says it has finished rescanning, and what I can just quickly do is do a refresh in my mailbox, and I should have the email now with the attachment. So what happened in the background is the system has actually managed to process the system. If I just go back to my Opswat email security, you see this is the initial email. We blocked it because it's password protected. It was blocked, but then we quickly provided the password, and the system managed to scan it, sanitize it, and then we deliver the email to the user mailbox. That's pretty much how it happens. Thank you.
So eventually I wanted to give you a feel of how a password protected file can actually be scanned. Generally we do not see that happening, right? So we generally expect that the file will be delivered and then the XDR or probably whatever endpoint solution that we have is going to inspect that. But again, that's the problem. Now it has already reached your system. If the file has already reached your system, it's already done. The damage is already done. The next demo or the next kind of a small video that I'm going to show is more on the CDR that I was talking about, how this is going to scrap out all the active components and how you can see how things are working in the CDR.
In this video, we will discuss Opswat's Deep CDR technology. Deep CDR is used to prevent both known and unknown malware from entering an organization by removing any active and potentially malicious content within that file. The file is deconstructed into its individual components, and any object containing active content is removed. For example, CDR can remove embedded scripts and documents, executables embedded within images, or append a safe redirect to hyperlinks. Deep CDR can perform this recursively, removing malicious content hidden and embedded deeply within other complex files. The remaining textual objects of the file are then recombined into a new, fully functioning file and delivered threat-free to the end user. Let's take a look at the demo to see how it works. Within workflow management, select the work.
So basically, if you would have seen the last slide, there was a lot of components on the left side of the slide which showed the document, and it had a lot of static and dynamic content, right? And on the right hand side, after sanitization, this went into only the static content. Now this particular thing can be done in a recursive way. So what if somebody sends a file within a file within a file, and then they embed an image in that, and behind that there is a source code. So we can do that scanning till that last mile, till that last level, and ensure that the file that you're receiving is completely malware free. So once this is removed, the sanitized file will be shared with you. This can now be even put in a quarantine. You have an option, you can right click, you can see that supposedly you want that file, and you say that, okay, no, this was a legitimate executable which I wanted, which was sent to me, and it was genuinely intended. You can extract that by your admin. All right. So these were just a few examples how we are doing things. There are a lot of things that we do. We have threat intel, we have sandboxing, we have file vulnerability scannings, and there are around 6 technologies around a single file that we work on at any given point of time. But yes, these were 2 examples which I wanted to show to you. That's it from my side. Thank you everyone for being patient.
Can we have a big round of applause for Mr. Ashwin one more time?
Thank you everyone.
Thank you so much.